This is section 8.3, and our goal is to use zero and negative exponents. Okay, so our first key concept is a zero exponent. B to the 0 power is 1. So anything raised to the 0 power is 1. B to the 0 equals 1. 5 to the 0 equals 1. So think about when we are canceling things. So for example, when we ended up with an x squared over x squared, we decided that anything divided by itself has to be 1, so that cancels. But think about what's happening in terms of our quotient properties. If we subtract like we normally do, 2 minus 2 leaves us with x to the 0. But we already know that that equals 1. So anything to the 0 power is 1, except 0. So when b is not equal to 0, everything else raised to the 0 power is 1. And this is why. Okay, our second key concept is with negative exponents. So b to the negative n is the reciprocal of b to the n. So for example, b to the negative n is equal to 1 over b to the n. Or for another example, 4 to the negative second power is equal to 1 over 4 squared. And same thing vice versa. So b to the n is the reciprocal of b to the negative n. So we can go in the reverse as well. If we have x squared we could write that as 1 over x to the negative 2. Or if we have a to the negative 4, that's actually the same as 1 over a to the 4th power. So just keep in mind that if we're asking you to simplify, the most simplified version is going to be where we've gotten rid of all the negative exponents. So we've put stuff either in the denominator to make it positive or in the numerator to make it positive. Okay, so let's try some examples. First we have 3 raised to the negative second power. So before you try to simplify to do 3 squared, we need to move that to the denominator. So that's the same as 1 over 3 squared. And we know 3 squared is 9, so that's just equal to 1/9. Alright, and then we have negative 7 to the 0 power. And again, you can almost think of that as negative 7 divided by negative 7, which we know is 1. Here we have 1/5 raised to the negative second power. If it's confusing seeing it written that way, go ahead and rewrite it. And that might remind you that we need to distribute that negative 2. So we end up with 1 to the negative 2 over 5 to the negative 2. And if we flip that to make them both positive, that's the same as 5 squared over 1 squared. Well, 5 squared is 25, 1 squared is 1, so we just end up with 25. Number 4 is a little bit tricky. 0 raised to any positive power is usually just 0. It is always 0. So any positive power, because even if that were 0 cubed, that's just 0 times 0 times 0, which is 0. But if we have 0 raised to a negative exponent, think about what that actually means. Because if we put 0 in the denominator, so we have 0 to the 5th in the denominator, well, we can't divide by 0. So that's undefined. Here we're combining some of our earlier rules. So we have 2x y to the negative 5th cubed, and you got to make sure you distribute that 3 to all 3 parts. So we have 2 cubed, x cubed, and y to the negative 15th, because negative 5 raised to the 3rd power. We're going to multiply, power raised to a power. And now to simplify, 2 cubed is 8. X cubed can stay, but then y to the negative 15th can go to the denominator so that it's positive. So if you left y to the negative 15th, it's not that you're wrong, but remember we're trying to simplify, so it's not all the way simplified until you've gotten rid of all of your negative exponents. Alright, number 6. Again, make sure you distribute to both, so we end up with 2 to the negative 2 times x to the negative 2 times y to the 5th over negative 4x squared y squared. First thing you want to do is move the negative exponents, so if I do that, I end up with negative 4 times 2 squared times x squared, y squared, all in the denominator, and y to the 5th is the only thing left in the numerator. So now, 2 squared is 4 times negative 4 is negative 16, so that's still in the denominator, negative 16. X squared times x squared is x to the 4th, and then I have y to the 5th in the numerator and y squared in the denominator. So 5 minus 2 is 3, or just think there's 5 y's in the numerator, 2 in the denominator. So 2 cancel and leave us with y cubed. So that would be your final answer. Okay, 2 more examples. Number 7. First thing again, get rid of that negative exponent. So I have 3xy to the negative 3 over 9x cubed times y. So I'm just going to go ahead and do the negative exponent first. So 3x over 9x cubed y, and then I'm going to have a y cubed in the denominator. So then 3/9, remember you're going to divide those like normal. You end up with just x over 3x cubed, and y to the 1st times y cubed is y to the 4th. And then we have x to the 1st over x cubed. 1's going to cancel, and you're going to be left with just a 1 in the numerator over 3x squared y to the 4th. Alright, and for the last one, 4/8 is going to simplify to 1/2. So you're left with a 1 up there and a 2 down there. And we need to move the x to the negative 2. So we end up with y to the 4th over 2x x squared. Remember, it becomes positive when you move it. And then y to the 6th. And this time I want to think about this a little bit differently. So think about our subtraction rule. If we have y to the 4th over y to the 6th and we subtract, 4 minus 6 is actually y to the negative 2. X squared and x is x cubed. Well, it's kind of like what we just talked about. If we have y to the negative 2, it moves to the denominator to become positive. So we end up with 1 over 2x cubed y squared. So when we talk about, how many cancel and where they're left, that's what's actually happening. The subtraction rule is still true. You just end up with a negative exponent that you then move to the denominator. So either way you want to think about it is fine, as long as you're getting the right answer.